In the previous videos, we got familiar with effect and the similarities of it with promises. In this video, we will look at effects from another angle and see how we can create effect values. So far, we know that the effect type is all about abstracting computations, especially computations that may have side effects. But here's the thing. We already have a tool for modeling computations, one that we used every single day, and that is function. As you already know, I like to think of functions as pipes. They receive an input from one side, do some calculation, and return an output. The kind of functions that we are really interested in are simply mappings from input values to output values. We call these functions pure. As I mentioned in the first video, pure functions are functions with some limitations. Maybe assumption is a better word. These assumptions make pure functions easy to compose and combine to create new pure functions. The great thing about pure functions is that you can move them to whatever context you want without any issues. Testing them are super easy because inputs always lead to a same output. This makes reasoning about them extremely easy. Imagine trying to fix a bug in a new codebase that you're not familiar with. If all we have is just pure functions and composition of pure functions, then pinpointing the bug is pretty easy since functions don't affect each other's behavior. But in order for us to create useful applications, our functions should be able to reach outside to do side effects. For example, how can we create a calculator app without being able to receive mouse clicks or not using terminal input and output? So we need them. On the other hand, the benefits of pure functions are so great that we still want to have them. The question is, can we somehow model side effects just by using pure functions? Let's look at an example. SaveUser is a function that receives a user, prepares some data, and finally saves that in a database. For simplicity, let's say db.save is synchronous and it returns a number indicating an ID of the record being saved in the database. So SaveUser receives a parameter of type user and returns a number. As you can see, this is not a pure function. The DB object is from outside of our function body, and if we run SaveUser, it will immediately cause a side effect and changes some state outside of this function body. This makes SaveUser not 100% reliable to be moved around, composed with other functions, and be used in different scenarios. We want to gain more control over the side effect part of our function. If we look closely, the bulk of what we do in the SaveUser function is not the side effect. It is preparing the data to be saved. The only part that we want to treat differently is the actual saving. So let's rethink our design. What if instead of actually doing the saving, we acknowledge that at this point of application execution, we want our data to be saved in the database? Not actually saving it, but to return some value that expresses this fact and is expressive enough so we can do the side effect later. Well, we know functions are values too. What about returning a function that wraps db.save? This will effectively delay running the side effect to a time when we decide to actually run it. In that case, now SaveUser returns a function which that returns a number, rather than simply returning a number. In programming, functions without inputs are called funcs. Think about how can such a function be pure. The only way they could be pure is for them to always return a same value. They are always mapping nothing to constant values. Not that useful, right? But if we consider and use them for our side effects, they can actually be quite beneficial. Alright, so far we could isolate and delay our side effects. But save user is still not pure and free as we want. Take a look at this db variable. db is a concrete value coming from outside of save user function. This may prevent us from copying this piece of code and use it somewhere else. How can we overcome this challenge? How about passing it to the returned function? By doing that, save user doesn't depend on existence of a concrete db instance from outside context, but instead it now depends on the db interface, meaning db instance required to be provided when we eventually want to run our program. So now we can easily call our save user function without needing to worry if our db instance is ready or not without doing any side effects. But there is still one side effect that we may have missed. What happens if db.save throws an error? Those kind of errors propagate outside of our function all the way up until somewhere it is being caught or crashes the application. You may say, well, this won't happen until we actually call our saving user1 function. True, but nevertheless, this is implicit and another side effect. In order to code and design well-engineered programs, we want to be in control of not only the happy path of the execution of our code, but also the error path. Let's put our db.save inside a try block, and in case it throws, catch the error and return the string representation of it. And also we need to update the output type of save user. And that gives us explicit control over the error channel. You see, what we are doing here is systematically trying to find a pattern to design a general guideline for dealing and controlling any side effect. And there's still more work. We can improve this a lot. Like, the most obvious one is, how can we differentiate between good and bad results? The other thing is, we started from a simple return type of number to a more complex return type of db to number or string. How can we use this output as an input to another piece of code? It feels like we are creating bigger problems rather than solving the first goal of taking control of side effects. Here is how I look at it. What we are doing is we are introducing necessary complexities because the simple way we used to do things was too simple to address all concerns and wasn't enough. If you've worked on a mid to enterprise systems in production, I'm sure there are parts of system that you are worried to look and change. And if you're not still convinced, I encourage you to take a leap of faith. The good news is you don't need to code to handle the steps we went through manually every single time. Effect library has already done that for us. We just need to use it. For example, if we want to implement save user with effect, it would look like this. Effect.try receives two functions, one for our synchronous db saving and the other for handling errors for it. All the previous boilerplate has been abstracted away in the effect type with many more features and benefits. Alright, now that we've learned how effect roughly models side effects, let's look at how we can create an effect value. The simplest way to create an effect type is to use the succeed function. Succeed function takes a value and wraps it in an effect representing a computation that successfully produces that value. For instance, when using effect.succeed12, you can think of it as a computation that always results in 12. So the type of its return type would be effect of number. The error and dependency type parameters are never, because this effect value can never be an error and is not depending on any dependencies. But what if we want to indicate that our value is a result of a failed computation in an effect? In that case, we use the effect.fail function. Looking at the type of our value constant here, since the output of effect can never be a successful value, the first type parameter is never. But the second type parameter, which is the type of failure, is a string. If it helps, you can think of effect's succeed and fail function as being similar to promises resolve and reject methods. Alright, that was straightforward for available values. Now let's look at ways to model actual computations in effect. A simplest computation can be a synchronous one, and we use effect.sync to define those. Effect.sync receives a tongue function. As you now know, it means it receives a function with no inputs and a possible output. The important thing is, this function shouldn't be asynchronous. So no promises or calling asynchronous callback functions. As an example for a synchronous operation, we can query for a value in local storage in the browser. Local storage is a web storage mechanism that allows websites to store key-value data persistently in a user's browser. Looking at the type of value constant, if an item with name theme exists in the local storage, it returns the string value for it. Otherwise, it returns null. So the type would be effect of a string or null. Notice that in our example here, we are considering null as a good value and only considering thrown errors as bad values. Since we know getItem never throws an error, the failure type parameter is never. The dependency is also never because we haven't introduced local storage as a dependency to effect. It assumes everything for our synchronous computation is available. If we want to make local storage a dependency, we need to do some work. But more on that later in the future videos. But what if our computation throws an error? This would cause what is known as fatal or unexpected error in effect.sync. For these situations, we can use try function. For example, here we are creating a new URL object. This obviously won't throw, but imagine a situation where URL input comes from somewhere else. Then in case of a bad URL input, this will throw. Since TypeScript cannot provide much information about the thrown errors, effect.try specifies the error output type as a general unknown exception type. It is not never because we specifically told effect our computation may fail by using the try function. But what if we want to help effect to narrow the failure type? We can do that by passing an object to try function. This object has two properties: try for the actual computation and catch property for when our computation throws an error. In that case, catch callback receives the thrown error and have a chance to do some computations over it and narrow it down to a more specific error. For example, here we are returning a string from catch callback. That narrows the type of our value constant to effect of URL and a string. Alright, we learned how to define synchronous computations. Now let's look at how to define asynchronous ones. Promise is likely the most popular approach for modeling asynchronous operations in JavaScript and TypeScript. To wrap and define a computation that returns a promise in effect, we can use the promise function. It receives a tongue function that is asynchronous, meaning it should return a promise. For example, read text from Navigator clipboard returns a promise of a string. Looking at the type of value constant, it would be effect of a string. The other limitation to effect promise input is the return promise shouldn't reject. In other words, similar to effect.try, by using effect.promise function, we are hinting effect that we know the return promise from our computation won't ever reject. And that's why the final effect type uses never as the failure type for our computation. But the read text can actually reject, and if that happens, we will get into fatal errors. By using tryPromise, we hint effect that we may get into a promise rejection. So now the type of our value constant would be effect of a string and unknown exception. Similar to try, we can narrow the type of the failure result by handling the rejection in the catch property. In our example, if an error occurs, we catch it and return an error object. As a result, the type of the constant becomes effect of a string and error. There is another popular way to model async operations in JavaScript, and it has been used a lot in Node.js. ReadFile is a function from fs module in Node.js that lets us to read a file from the file system. It receives the path of the file we want to read from and the encoding of its content. For the third parameter, we need to pass a callback function. It is being called when readFile finishes reading and parsing the content of the file. In case of an error, it fills out the first parameter, and in case of successful reading, it fills out the second parameter, which we have shown it with data. Calling readFile doesn't return anything. The continuation of readFile computation in the application flows through the callback function. What we want to do is to wrap this computation and capture the data and error in an effect value. One possible way is to wrap this code in a promise and use effect.tryPromise to create our effect value. But effect library has provided us with an easier tool for this. We can wrap our readFile call in an effect.async and use the resume function provided by the async function to return the result. The input to resume is another effect value, which gives us the opportunity to specify whether the result is a success or a failure. Consequently, the type of our constant becomes effect of a string and error. So far so good. But sometimes you may need to postpone creating your effects. To do that, you can use the suspend function. Suspend receives a callback that returns an effect value. Looking at the type of our value constant here, it would be effect of number. And that's all the functions I wanted to go through in this video. To summarize, I've listed all the functions we went through to create effects with their inputs and outputs. If you notice, effect doesn't care if your code is synchronous or asynchronous. Both are abstracted under the same effect type, meaning you don't need to worry about handling them differently, which is pretty powerful and a convenient feature. And with that, I hope you enjoyed this video. Please like and subscribe, and I will see you in the next one.